Hello, welcome to Dubeke Consult. Our custom here is picking any piece of architectural drawing and we'll walk through these processes to achieve a detailed report that is applicable and easily workable by the artisans on site. This is our current victim. These are the views of the current architectural piece we've been working with. And after the last class, we were able to achieve the structural frame or the general arrangement that we'll be using in designing this structure. So we'll be doing this design on Prota Structure. If you've not subscribed to our YouTube channel, this is the best time to do so. And also turn on the notification bell so you get notified anytime we post new videos in this series. If you need to see how we are able to come up with the general arrangement, there is a link in the description for you to see that. Okay. Coming back to AutoCAD, this was our ground floor plan, which consists of the car park. This was the first and the fourth floor plan, while this was the second and third floor plan. Lastly, this was the roof plan. And we worked together to see how we can transform this into this. So we agreed that this will serve as our ground floor structural layout, while this will serve as our first floor structural layout. So to model this on Prota Structure, I have to export this ground floor in a DXF file format. And to do that, I will select this. Mind you, I will advise you copy these beam lines. When you want to do this, I advise you copy these beam lines on this ground floor that you want to export to the Prota Structure, because this will help you in tracing the positions of these beams. Okay, so what I will do is I will check the layer of these beam lines and it's under structural bearing pane 147. So I will select all of this, right click, come to quick select, come to layer, structural bearing 147. Okay, and I will copy this. I'll copy with this base point intersection between 1 and A. So I will select this, come here and paste at the intersection between 1 and A. All right, so I will paste this here. So now we are good to go. Let's export this to Prota Structure. So I will type W, which stands for block. Ensure you click on these three dots so it gives you the opportunity to save at your desired folder. And I will call this, ensure this is in a DXF file format, not DWG. Any of the DXF file format is okay, but I will go in with DXF 2013 and I will save this. All right, so the next thing to do is we go to Prota Structure. So when I open my Prota Structure, this is my welcome screen. I will come here and click on this new project icon and I will save this as modeling underscore class 1, class 2 rather. Then click OK. Then I will choose my desired code of design. So I'll be going with BS8110, or I can come here and select any of my previous projects I've designed with BS8110. But let's start afresh. I will select BS8110 and import the parameters. Okay. And this is our blank drawing. So to import that into Prota Structure, what I will do is I click on this external reference drawing icon, or I come to File and Model / Import. Then there's an option for external reference drawing. Okay, so I will come here and click on Load. It takes me to my folder, so you can select the folder you saved your file. I'll click on this and click on Open, and I will leave the unit at millimeter. So I'll click on OK, then come back to this part and click on Import Members, because I want to import my grid lines and the columns that I've created from AutoCAD. All right, so I will click on Import Axis and let's go and look at the layer of our axis on AutoCAD. So coming to the layer of this axis, if we select this, you will see is on A axis. Okay, this is the one on vertical direction. Then the one on the horizontal direction, let's look at this, is also on A axis. All right, so let's also check the layer of our column. If I click on this, is under layer columns. Okay, so we'll come back to Prota, and on the axis we'll come here and select A axis, direction 1, direction 2 as well. We'll select A axis, For the columns, I'll click import columns and I will leave it on this columns layer. Okay, so I'll click OK here. And the next thing is I will do a quick model check to see if I have any overlapping members. So I will click on start and check. Model check is completed. Number of errors 0. So we have no error on this model so far. Yes. So cancel and close. And with this, we've already imported our columns. So let's right click and see what we've done so far. So this is the columns that we've inserted from our AutoCAD rather. We've inserted this. We've exported this from our AutoCAD to our Prota structure. So the next thing is, let's take a look at what we intend to model today. For this modeling class, let's move in this sequence. We'll start by modeling our lift or our shear walls, then we'll move to our beams and to slabs, then finally we apply our wall loads on these beams. Okay, so let's start with our lift and shear walls. To model our shift or shear walls, there's an option for wall here, or we'll come to concrete members and click on wall. Okay, then this is the weight of our wall. We'll leave this at 250 and we'll come here and ensure this is at the center, so we'll get 125 mm a piece. All right, so we'll leave this at 250 and 125 at center. So we'll come to our lift position, which is over here, and we'll click from this grid to this grid, then we'll click from here to there, and lastly here to this part. So we'll leave this other side because this will be used as the entrance to this lift. Okay, so we'll model only this. So we'll model only these three parts. All right, so we'll go ahead and close this and let's take a look at what we've done. So these are our lifts or shear walls. Okay, so the next thing is we have to start to model our beams. Now, to model our beams, it will be very easy for us because we've already inserted these lines which indicates the positions of our beams. Like we said while we were making the general arrangement, we said these lines indicate the positions where we intend to run our beam. This is one reason why it is advisable to do your general arrangement on AutoCAD, so you can as well make all these modifications, and this becomes very easy for us. So to model our beams, we'll click on beam here, or we'll close this, come to concrete member, click on concrete beam, and we'll take our width to be the same as the width of our wall, which is 230 mm. So type 230 here. Then the thickness, okay, let's assume a thickness of 600 mm. And if this is not sufficient, this for the ground floor, considering the fact that it's going to 4-story, that is a ground floor plus 4 other story, let's assume 600. I believe this should be sufficient. If it's not, there are options for increasing this after design and during the process of design. Okay, so the next thing is we start to trace these lines that indicates our beam positions. So I'll click from this grid. What we'll do is we'll start from the left hand side, then we'll move on to the right hand side so we don't confuse ourselves. Okay, so I will start the horizontal beams. I'll start from here to this part. This is the last point for this. All right, then I move to this, okay, I'll move from this column to this column. Is not continuous here, so we jump and move from here to this part. Okay, then I move from this column up to this column. All right, then finally I'll come from this part to continue till this part. Okay, now we are done with the horizontal beams. Let's not forget that we missed out these beams because these two beams are resting on this vertical beam, so we cannot create this at this very point in time. So let's go to our vertical beams. To create our vertical beams, we'll move from this point to this last point. And before we continue, let's take a look at what we've done so far. Let's come here and come to 3D view. Okay, so these are our horizontal beams and one of the vertical beams that we've created. So let's come back to plan, right click, come to plan, click on any of these beams, right click, come to properties. So it takes the properties of the already existing, the beams that you selected. So we've done this one, and we'll move to this, from this point to this point. Okay, from here this one goes down to the last point, which is here. Okay, next is from here to this part. All right, the next is from this point to this point, and it will rest on this shear wall. Okay, then also a beam will come from here to this part. All right, so let's come down to this part. We'll click here, and it stops at this beam. Okay, we'll create this as well from here to here. We'll come to this, so this point, and also to this point. Okay, then we have one here, from here to this part. And let's not forget the beams at this void. Okay, these two beams. And let's see what we've done so far. So we've successfully achieved the left hand side. Let's see if we have any horizontal or vertical beams that are missing. I believe we do not. So let's close this and come to our 3D. We'll right click, and this is what we have done. All right, so let's go back to the plan and achieve the right hand side. So I'll use the same method. Start with my horizontal, then come to my vertical. So from here to this point for this. Then let's go to the vertical axis. A beam will run from this part to this part, and it will also rest on our shear wall. Okay, we'll save this, or we'll draw from here to this point, and also to this point. Okay, next is this, and also we have to model this, our void positions. All right, now we are done with our beams, and let's take a look at what we've done so far and compare it to the AutoCAD. Okay, so I will right click, come to 3D. This is what we've done so far, and let's compare this with what we have on the AutoCAD. So I'll move this to this side, and I'll put my AutoCAD over here. All right, so this is what we've achieved. Let me drag this a little bit. Okay, so let's see if we are missing anything. I think we are missing this beam over here, so we have to get the position of this beam. Okay, so from the edge of this to this, we have 1.2. So that means from the center line to the center line will also be 1.2. All right, so we'll come to this first grid. We'll come here, we'll right click and go to offset axis. We'll move it down. Then you press the F2 on your keyboard to allow you edit. Okay, and you type minus 1200 because you are going downward. If you are going upward, there's no need for the minus sign. So you type 1200 and hit enter. Okay, so click on any of these beams. Let's click on this. We'll right click, come to properties. It takes the properties. Then we'll click from this point to this point. Okay, and close this up. So now I think we don't have anything missing. All right, we don't have anything missing on this, so this is okay. And let's have a look. Okay, there is one beam missing here. We'll come back, So our plan, we'll click, right click, properties, click, and this. While making your modeling, you should ensure you are not in a rush, because if you are in a hurry to complete your modeling, keep in mind that this modeling will be considered during your analysis. All the conditions you put here, if there are missing links, if there are missing beams, this structure will be designed with all those conditions. Okay, so always ensure you are not in a hurry, you are not rushing when you are working with this modeling. Okay, so let's confirm if everything is intact. I think we are good to go. We don't have any missing or omitted members. All right, then the next thing to model after this is our slab. So to model our slab, we'll come here to slab, or as well go to concrete members and click on slab. But let's just come here to click our slab. All right, and we'll start with, we'll assume a thickness of 150 mm, 150 mm. Okay, then the concrete cover, we'll leave this at 25. In case you are confused on what to choose, go back to our previous video, modeling class 1. You will see in that video we extensively explain the conditions that should guide your choice of adequate concrete cover. Okay, but we'll leave this at 25. Then we'll come to our loads. Okay, and on our dead load, we assume our partitions to be 1.0. Then our finishes, let's assume that to be 1.2. So 1.0 and 1.2 together will be having a total of 2.2. So I will type 2.2, and for this part I will right click and I will select residential, general domestic use. Okay, because this is a residential structure. Then I will start to position my slabs in between my beams. Okay, so I will come here and I will position these slabs. Okay, this is my first slab, and come to this part, another slab here. Let's not forget that there is a void over here. Okay, this part is a void, so there won't be any slab. And also this place is left specifically for our staircase, so there won't be any slab at this region as well. Okay, so a slab here, and another slab, another slab. Okay, before we complete this, let's take a look at what we are doing. I'll come to here, right click, come to 3D, and you can see these are our slabs. All right, so let's come back, right click, plan, click on any of the slab, right click, come to properties, so it picks the properties of that slab. You can see the same property. We'll come here and we'll click here, here, this part, this part, this, 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 and this. Okay, so this is our void. All right, so let's close this and come to our AutoCAD. So if we maximize this, you will see this is the position of our void. Okay, this was created, let's look at the architectural drawing. This was created to provide ventilation to this room, so there is no need to insert a slab at this very point. Okay, so let's go back to Prota, and I think we are done for the left hand side. Let's have a 3D look. So we have all the slabs positioned except for our void. Okay, so now let's move over to the right hand side. To model this, I'll click here, and one more thing, let's insert a beam over here. Okay, so this part will act as a panel, right? So this other part can be considered when they are inserting the shear wall. So we'll come to this, we'll right click, properties, and we insert a beam right over here. So we'll close this up and close. Then we'll come back to our slab, click, right click, properties, we'll put one slab here, we'll leave this part empty, we'll come here, right click, and look for 3D. If you found this video helpful to this point, kindly like it and subscribe to our channel. Also turn on the notification bell so you get notified anytime we post further videos in this series. So we are done with these slabs, and the next thing we have to model is our cantilevered slab. Okay, so if we come back to our Revit model, you will see that we have our cantilever. This is the Revit architectural model, not the structural model. All right, so if you come to the architectural model, you'll see that there are slabs, cantilever slab at this point. Okay, and this cantilever slab, like this, you can see this part, this is very visible. All right, so from the column there are cantilever slab coming to this point, and on this cantilever we have cases where we have our block wall running on them. Okay, so what we'll do to cater for that, we have to insert our parapet load on our cantilever slab. So let's go back to the 3D, the Prota structure, and these are the positions where we indicated for our cantilever slab. Okay, these positions and these other ones. All right, so we'll go back to slab, and in this case we'll move from type 1 to type 12. Okay, if you want to understand all of this, I will appreciate if you go back to modeling class 1. In that very lecture is a very simple residential structure, and we took out time to explain most of these things in details. All right, so we'll come back to type 12, which is our cantilever slab, and we'll leave this at a thickness of 150. Then our cantilever, let's come to our AutoCAD and come here. If you dimension our cantilever, we have a length of 1.2. Okay, also this, we have a cantilever width of 1.2. all right, so we'll come back to Prota, and our L count, okay, we will leave this as 200. All right, let's come to load. Our load, we will leave this as it is. Then our parapet load, okay, our parapet load, we said we'll insert parapet load because we have walls, okay, on our cantilever slab. So we say we'll insert a parapet load to counter these walls that are coming on this slab. So there's a wall here, we have another one here, and if you come to this side, we also have walls here. All right, maybe during construction they might even decide to put this wall on this other part. No, we can't tell, so we'll have to run a parapet load on this cantilever slab. So I'll come here and I'll make reference to a design material. I'll come here and I'll make reference to Fundamental of Reinforced Concrete Design by Victor O. Oyenuga. You can get this material online. Then I'll be using the unit weight of our wall. So let's come to, you can come to table 2, which is on page, this should be page 3. All right, so our block wall 225 hollow block, the unit weight is 2.87 kilonewton per meter square. So I will use this, which is 2.87, and also I will use this for my wall load. Okay, so I will use 2.87. I'll minimize this, come back to this part. All right, and I will type parapet load as 2.87 kilonewton per meter square, and I will come here, click on this part, click here, and take my cantilever to the left. Okay, that's it. Come here, click here, take my cantilever to the left, and both of them will join at this point. Okay, so let's take a look at what we've done. So let's come to 3D, and you can see this is our cantilever slab with our parapet load. Okay, so let's see what happens when we do not include this parapet load. So we'll come back to our slab, still on type 12, then come to our loads, and we'll leave this at 0. All right, and we'll click from this point to this point, and we'll take this here. Let's close this and have a 3D view. Come here, right click, come to 3D. You can see there are no indications of parapet load. Okay, we don't have this indications that there's a parapet load running at these edges. So what we'll do is we'll come back to our plan, click on this slab, right click, come to properties, come to load, and we'll take this back to 2.87 and update. Okay, update and close. So let's go back to C 3D, and as you can see, our parapet load has been included on the cantilever. All right, so I'll right click, go back to plan, click on this properties, then I'll draw from this point to this point. Okay, and I'll take it to this part, so it will cojoin at this 45-degree angle. All right, so the next is this, still the same properties to this part here. All right, come back to here, click this part, take it to here. Okay, then for this aspect I want to let's do something different. Okay, against having just a complete cantilever slab, let's support this slab coming here with a beam. Okay, this is just to show us a different way we can decide to model. Okay, let's do something different at this very edge. Instead of sticking with just cantilever slab on this edge, let's create a beam. So I will come to this beam, right click, come to properties, click here, and we don't have any grid here, so this width is 1.2, and to have 1.2, it means from the center to the center of this we also have 1.2 meters. Okay, so I will click on this, right click, come to offset axis, then I press F2 and I'll type 1200. There's no need for minus because we are going upward. All right, and click enter. So I will come back to my beam, come here, properties, click here, so this point, come here, click this. So okay, we need to offset this as well, so I will come back here, come to offset axis, we are going towards the right, no need for minus, F2 1200. Okay, click properties, right click, okay, click here and click this and this. Okay, so next is our slab. We'll come to slab and we'll go back to type 1 because this is no longer a cantilever slab. So this slab now has, this slab is now supported at this edge and this edge. So we have 3 edges supported, so this does not count as a cantilever slab anymore. Also, this does not also count as a cantilever slab. This little part here, we have a beam here, so we have this slab supported at 2 different edges. All right, so we'll come here and click to create this slab. Then to create this one, we'll come to this part and click on insertion. Okay, and we'll click pick axis. Let's click on pick axis. So we want to insert within this axis over here, this 4 axis. So I will click on this. This is the start point here. Okay, and it flushes with this part. It goes up to this part, this grid. Okay, comes back to here, and finally it comes back to this point. Okay, so our slab has been inserted. The next is this other part, so we'll delete all the previous axes. It starts here from this grid, it comes and goes to this grid, so we'll click on this, comes to this part and goes here, so we'll click on this, moves to this part and cojoins this, so we'll click this, and finally we'll take it back to the last grid. All right, we'll delete all of this, then come back to beam rejoin. Let's close this, close, then have a 3D visual interrogation, right click and 3D. Okay, so against having just a cantilever slab, we can as well decide to support this with our beams. I'm just trying to show you the different ways in which different structural engineers can decide to model cases like this. Okay, so let's come back to our plan, and the next thing is to insert our wall loads, because on all these beams we have walls running on them. Okay, so to insert our beam wall load, We'll still go back to our design material, and let's check our wall loads. The basic weight is still 2.87. We'll be working with this 2.87 for a 225 hollow block. Because we are assuming a width of 230, we can take this to 3.0. We can assume this to be 3.0. All right. So we'll come back to our Prota, and we'll click on any of these beams. Okay. We'll right click, come to edit beam wall load. So what this is doing for us is it will take the weight of our wall and apply it on these individual beams. Okay, so that's what we are trying to do. We are trying to cater for the load imposed by the walls running on our beams. So I will click on any of the beams, right click, and click on edit beam wall load, and the wall unit weight is 2.87, but to say we'll assume 3 in this case. So I'll type 3 over here in kilonewton per meter square. And the height of our floor, the height of each floor, all right, is 3 meters. And our wall thickness is 230 which translates to 0.23 millimeter. 0.23 meter rather. So I'll type 0.23. Okay, and if you look here, automatically our dead load which will be applied on our beams has been calculated to be 9.0. Look, observe this when I change this to 2.87. Okay, you see the calculation has changed. All right, so let's take this part to 3, and we'll click OK. All right, so the color of this will change to show that beam wall load has been applied on this. So let's have a 3D visual interrogation, and you see a wall has been applied on this very beam. All right, so we now have a wall running on this beam. Okay, so let's come back. We don't necessarily need to create for all these beams. What we can do is we just click on this, right click, and come to copy beam wall load. Okay, so we'll copy this, then we'll come to this structure wizard, and we'll click on the first beam on this story. Come here, hold shift, click on the last beam. All right, right click on them and paste copied beam loads. Okay, so we'll click here and okay. All right, so now we have our walls on all the beams. Okay, then let's come back to this part. Come here, right click, and say a 3D. So we have the walls running on all these beams. Okay, before we move to the next story, so I think there are some missing cantilever slabs over here, and let's look at this cantilever slab. If we come to the Revit model, okay, and you look at this part, this is the little cantilever slab that we have to model. And let's come to our AutoCAD here, and as you can see, the width of this cantilever slab, we have this from edge to edge as 450 so our L count will be 450 in this case. So we'll have it here is on our balcony. Okay, so this is 450 as well. So let's come back to Prota, and we'll come back to our slab, and in this case we'll go back to our type 12. Okay, so our L count in this case changes from 1200 millimeter to 450 and considering the fact that we can have walls running on this part as well, we'll leave our parapet load to be 2.87. We'll add our parapet load here, come back to this. Okay, then we'll click on this point, so this point, and we'll insert this little slab. Okay, come here, click on this part, click here, insert this slab. Okay, we'll do same for this part. Click here, insert this slab, and the last but not the least, this part to this part, and I believe we should be done with modeling the story 1. All right. Okay. So now we are good to go. So now we are done with modeling the story 1. The next thing is to generate this story to the other stories. And we said while we are working on this, we'll try our best to always reduce our member sizes. Okay, we will try our best to always reduce our member sizes as we move from story 1 to story 2 to story 3. If we had a 600 by 230 beam on the story 1, it doesn't mean we have to maintain the same size going up to the fourth floor. So now that we are done with this part, the next thing to do is to generate our story. Okay, and to generate our story, let's come to our Revit. And from our Revit, you can say we have story 1, 2, 3, 4, and 5. It's a 4-story plus a ground floor. So this acts as 1, 2, 3, 4, and 5. We have to pause this video at this point. Do well to look out for the part 2 of this video to see how we generated these stories and in turn reduce these member sizes, considering the fact that if we keep the same member sizes from the first floor to the apex, we will just in turn waste our client's money. Okay, so kindly subscribe to our channel, follow, and if this video has been helpful to you, like it, subscribe to our channel so you don't miss out on when we post subsequent videos in this very series. Thank you very much.